Many IoT devices are running on battery because they are in remote locations, because they're not always connected to the grid. That can be very efficient, but batteries have a limited lifespan and there's limited things you can do in terms of compute on devices powered by batteries. How about harvesting energy from the environment? It's called Ambient IoT. Bjorn and Jeff are experts, whether it's about measuring and optimizing software and hardware for energy harvesting and consumption, or it's on the production of efficient modules and hardware for harvesting energy, like solar, for example. There are caveats. It's not always the right solution. We're going in the right direction, though. This episode is sponsored by IoT Stars, and we really thank them because their goal is to emulate and trigger interesting and real conversation around IoT. And this one today is really about a real conversation because we'll talk about the economics as much as the technology itself when it comes to harvesting energy on IoT devices. Once again, do not forget to subscribe to the channel, to give us a like, to leave a comment as well. We'll really appreciate that. Hey everyone, this is a new episode of the IoT show, and today we'll talk about energy harvesting devices, ambient IoT, and a bunch of super interesting things that you developers and IoT practitioners will need to pay attention to. For that, we have Bjorn and Jeff. Let's do a little quick round of introduction. Let's start with you. Bjorn, who are you? Where are you calling from?
Yeah, nice being here in the show. So my name is Björn Rosqvist. I'm a Chief Product Officer at Qoitech. Qoitech is a company that make a cutting-edge solution for power analysis and battery emulation, battery and energy harvesting testing for embedded devices. So we have been into this subject regarding both battery power devices, energy harvesting devices for quite some time.
That's awesome. Jeff, what about you?
Hi, my name is Jeff Crystal. I'm one of the owners of Voltaic Systems, and we make solar panels and solar power systems for hardware devices. We're based in the Brooklyn Navy Yard in New York City.
Awesome, cool. Yeah, I'm great to have both of you here because on one side we have you, Bjorn. We'll be talking about the tooling that is necessary to build that ambient IoT thingy that we're gonna define and talk about, or energy harvesting devices. Then Jeff, yeah, you're concretely talking about building the devices out there. So, and you guys are collaborating a lot, so it's going to be a very interesting conversation. So it's super important to consider energy consumption and production, holistically. It's something that, that's why we have both of you guys here. Can you tell us a little bit about the shortcomings of these battery-powered devices in general? And then we'll talk also about what it means for developers. What are the limitations and things you need to consider when you're powered by a battery?
Working with batteries is always exciting because we talk about black magic. Batteries is one part of the black magic, and I think also antenna design is also considered as black magic. But so with batteries, there are problems that you will face when you develop IoT devices. But I think one major thing is that if you develop a device that is going to be measuring for a long time, if you need to replace the batteries, that could be a real business case killer, because having someone traveling around to all the locations, finding the different sensors and all these spots, it will be very costly to do this. So, if you do wrong design, so you need to replace the battery earlier than you was expecting, this will be a disaster.
Gotcha. Yeah. What about you, Jeff? What do you think?
Yeah, I think in some ways batteries are simpler because there's a fairly defined capacity. It can vary based on temperature and environment, but it's fairly defined. You know how much power you have. I think hardware engineers typically know how to work with them. I think I have a friend who is deploying a network of sensors in New York City, and he had built into his model in year 4, year 5, he would have to have 1 to 2 full-time people going around replacing batteries. So you think about sort of the ecological waste of this, but you think about the cost. I think there is an upfront cost to building in energy harvesting in both sort of intellectual sort of property as well as some BOM, but maybe not as big a BOM as you think. But I think the bigger one is the long-term maintenance cost. These things are often in places where it's hard to get to, and swapping batteries doesn't scale.
Yeah, interesting. Well, these are kind of obvious once you've been mentioning them, right? You're just like, oh, okay, yeah, true. That's something I need to consider. Is it fair also to say that, especially I live in the US, the grid is not that smart and not that good? Is it fair to say that, having a reliance on a grid and energy provider from the outside is also something you cannot really, like, that's one of the reasons that you would switch to a battery, right? And so that's something that you need to evaluate when you go with battery. You have a known cost and a known lifespan for your device. When you're using the grid, you might not be super confident that your thing will be powered all the time, and how much is going to cost. Maybe energy costs will go up, and you need to consider having devices that are self-generating their own energy. And that's why we want to talk about this concept of ambient IoT today. So can one of you give me a definition of what ambient IoT is?
Ambient IoT is you get energy from the environment or something around to also get power. I mean, ambient IoT, it doesn't mean that your battery less. You always have some storage. And I would say that in an energy harvesting system, ambient IoT system, there's always a couple of components. I mean, you always have some energy harvesting system that get energy from sunlight or indoor light or a vibration or thermal or something like that. You have like a central piece, the power management IC that handles the power flowing through the system coming from the harvester into the storage. The storage could be a rechargeable battery, it could be a supercap, it can be something like that. And then, of course, you have the consumer, the IoT device that do radio transmission, send some data, and so on. So, I mean, that's the basic components in these systems.
Sounds good. Yeah. And should we think of it as a way to get infinite energy? As in, like we'll talk about solar as an example, and I see you, Jeff, smiling. So it's like, is it something you can say, hey, it's around you, wind is not going to go down, tides and waves are not going to stop, and sun will still be shining. So is it a fair statement to say that when you go in that direction of energy harvesting devices, you basically tap into an infinite source of energy?
Yeah, for me, it's not quite infinite in the outdoor world. So most of our products are going on things like shipping containers, tractor trailers, cows. So there's a real environmental stress from those environments. So UV is the biggest one, but it could be saltwater, chemical spray, et cetera. So we're trying to get to 10 plus years in most cases, and longer in many, but we're not quite at the infinite state. I think if you were inside a manufacturing facility and you weren't exposed to some of those environmental variables, I think you can certainly do that. I think especially if you start to lean away from, say, like a lithium-ion battery chemistry to something like a capacitor. Infinite's a tough word in hardware, but I think certainly a long time, and that's the value to our customers is certainly for us is how long can this run before needing to be replaced.
And also, even if the energy around us is infinite, there will, as you say, Jeff, there will be stress in the system. Also on the storage. The storage will not be infinite storage. There will always be degradation in the storage when you put in energy and take out energy. So, I mean, there's a limitation there as well.
Yeah, no, that makes sense. But the limitation is in what we're using to harvest and store the energy. The energy itself is out there. It's renewable, right? So that's what we call it, renewable energy, and that's something that tapping into that in an efficient way. And that's why we are talking about. That's what we're talking about today. How do you efficiently harvest that energy, store it, and what are the things that's going to happen that might not be, working or that you have to consider. And that's definitely something, Jeff, I want to turn to you and ask you. So infinite energy potentially, and technology that is evolving really fast to harvest and store that energy and live a long life. I know solar panels a few years ago were something that people were hesitating to put on rooftops because they were just like, hey, in 2 years, I'm going to have to change every cell because they're going to be worn out and they won't produce enough anymore. Things are evolving. Do you think solar is something that's going to take over? And is it systematically the right solution for energy harvesting devices out there?
Yeah, I think we're not quite like ChatGPT, where we double every year or every 6 months. We are. When I started, solar was around 17% efficient, and now it's 24% efficient. So it's getting better. I think we're getting a lot better in durability, and the cost of it's going down. I think really what's happened is the energy consumption of a lot of things, like for example, edge AI, or how much energy it takes to transmit data over a long way over LoRaWAN or cellular. Those have gone down quite a bit. So the cost to send data has gone down. The cost to create a solar panel has gone down. The efficiency has gone up some. But so I think what we're seeing is as the cost of all those peripheral parts of the system, so the energy harvesting chip, the cellular modem has gone down, it's enabled sort of new business cases at scale. So you're now able to put, say, a device on a cow collar that tracks the cow collar location and creates this sort of virtual fencing system for livestock, which economically you weren't able to do 5 years ago. So the economics, to me, in my mind, have shifted, and sort of the tools available for the developers have shifted much more than, say, how much light can the solar panel harvest.
I mean, as you say, the evolution of the chipset is also going lower and lower in current consumption. That means that it enables more and more energy harvesting solutions due to that the need of energy for the devices is lower if you, of course, do the development right and don't mess up your energy consumption, of course.
Yeah. Can I give you an example about energy harvest? So a couple of years ago, we built using Raspberry Pi, like an acoustic monitoring application for to do bird calls, and we needed a 50-watt panel, something like this, and a big battery, and it was quite clunky. And then, about a year and a half ago, someone built a new application called the Bird Weather Puck, which again listens constantly for audio signals, processes, and then identifies, okay, that's a warbler, that's a kestrel, and now we're running it on a panel this big, and I think it's just going to continue to go, and that evolution of chipset technology and lower power consumption enables sort of us to use to scale up something and use a relatively small panel to power something that's pretty amazing.
Yeah, I imagine there's no magic tool to evaluate, how much a solution is going to cost and how long it's gonna survive. But I'm wondering, Björn, because you're in the domain of tooling and instrumenting and measuring and optimizing, what are the main ways developers, in particular, whether they're hardware and software developers, how can they approach that problem if they're ahead of a project and they're just like, hey, should I go with energy harvesting on that one or not? How do you recommend them to approach this problem?
Yeah, the solution is always use case dependent. What are you building it for? There is not one solution for this, but it's with the right tooling, it's pretty simple to start working. The focus to start with is, of course, to have a low current consumption for the communication part and the measurement and calculation part, because if you have that optimized, that makes it easier to select the energy harvesting part. And then you can go and see how much energy do I really need. And then you can start looking at different PV cells, like Voltaic's ones, and see how much energy can you actually get from them. And it's pretty simple also to test this. Of course, to test it in different conditions might be the tough task to do it. To be out the door in minus 40 degrees in a sunny winter day or something like that. to do all this testing in the lab, it takes some skill and some tools to do that. And we help the developers do this, to do the testing in their lab instead of standing freezing out the door doing the tests there. So I mean, there's always a start to do the measurement, and it's to see that you have a net positive energy flow into the storage. I mean, that's the key to this.
That's the goal, definitely. Jeff, do you see customers coming to you with that very question, which is, okay, I understand the importance of renewable energy and the advantages, but how do I know when it's going to be profitable and when I'm breaking even?
Yeah, it's typically not like the economics tend to be around their service, which I think is a challenging question. But I think what they're typically coming to us is saying, I think solar is going to work, and so the conversation is sort of similar to what Bjorn said. Is we say, how much power are you using? And I think there's always some variability because in the wild is different, but the best ones they're using a tool like Qoitech, and they understand the characteristics of their power consumption. And then Voltaic has enough experience where we can say pretty easily, here's how much power we think you can produce, and here's how big of a panel, and here's how big of a storage element you need. And then I think you can get pretty quickly to a BOM where you say, here's how much this is going to cost to build this thing. I think what's different about sort of ambient energy versus like a battery is that there's a probability that's thrown in. So if you think about a battery, you're like, yeah, here's how much capacity I have, and I'm going to deal, or I have a grid, and here's how much power I have from the grid. Now we're saying this could be, in a field in Texas, or it could be on a shipping container in Sweden, and it could be facing north, and the weather could be really nice for 10 days, or it could be cloudy for 20 days. And so getting sort of people to switch to this idea of probabilities and averages versus certainty is a shift, but a fun one.
Definitely. So what's the role of, we talk a lot about hardware, capacity and technology for harvesting the energy efficiency and things like that. What's the role of software? I'm coming from the world of embedded software where it has been a question of like optimizing software to run on less hardware resources. Now we're getting more and more hardware resources. Like we're getting more memory, we're getting like stronger CPUs and or microcontrollers, and now we're starting to get NPUs as well to run some AI down there at the edge. How important is the role of the developer to optimize software, as well for energy consumption and production?
Yeah, I mean that's really important. Cannot state that enough. I mean you can ruin any design with bad software. So that's that's how it is. So but it's very easy. I mean, if you continue, if you take responsibility, if each person in the project take responsibility for the energy consumption, there will be a good design. I mean, if you are a firmware developer, make sure that you do your measurement and that you do not ruin the power consumption. And if you are a higher level application developers, it's your responsibility as well. It's not someone else that is going to run after and fix all the problems. So I mean, it is important.
And in general, there's something that I'm seeing more and more, and we'll talk about AI real quick just after, but software update is something that's becoming more important, not just for fixing, security issues, but also for adapting. You were telling us, Jeff, that depending on like exposure or weather conditions, you're going to have different level of energy you can count on. And so that could be a good use case for updating software in ways that it can be adapted to the conditions, and you can forecast conditions. So you can eventually, push software updates or configuration over the year for devices or remotes for them to adapt their consumption and the way they're going to store energy based on the forecast for the weather in the case of solar. And that involves AI eventually, where you can have models that are pretty powerful that can retrieve information from the environment and determine that they will need to start, storing more or picking from the grid a little bit for a more expensive source of energy, but to be sure to be facing the next big cloud or bad days of coming up. So I'm wondering, how much impact can AI have at the edge, both positive and negative, on this concept of energy harvesting?
Yeah, I think there's multiple parts to it, obviously, and I think we're seeing it obviously being deployed with our customers. I think I think about this example of like a sheep with a kind of a health monitoring application on it, and so that what we could do is take all the data about the sheep, velocity, vector, temperature, heart rate, et cetera, and send that data every 15 minutes over some networking. And there's cost of that because there's data cost, there's a processing cost on the other side. Or we could process that at AI level and say, okay, the sheep's healthy, and every 4 hours say, okay, the sheep's healthy. And then if something happens where we need to send an alert, we send that data. So you're pushing data consumption and energy consumption to the edge and processing power in exchange for data costs and data transmission costs, because it takes energy to send that data. I don't know exactly where it shakes out in every place, but it seems like in this case, at least, you'd rather have that processing at the edge, not send all that data, not take all that energy to send the data.
Yeah, I agree. And I mean, it's not one solution for all this. It's pretty simple to see the cost in energy. If you go to higher processing out in the edge, it's pretty simple to do the measurement. How much does it cost in energy? What is then the cost? Do I need to have a bigger solar panel? What is the cost of doing this? And also, I like the idea that you said, Jeff, with a device in, let's say, northern Sweden, facing north in the winter time. There is not much sunlight. Maybe you should have AI to predict if it is okay to send out a firmware update to that sensor. Because if you send a firmware update in the middle of the winter in Sweden, in bad conditions, the sensor will most likely die during the firmware update. So maybe that's where we should use the AI.
I can see the conversation in the ship room. So we can't send that update tomorrow because it's going to be raining. What?
Yeah.
That's true. That's true. I remember seeing some tools that would allow an embedded developer to see the estimated consumption of each of their function in their code directly. And that's something that is pretty powerful when you're an embedded developer. Because, hey, if I run that loop, with that kind of functions in there, it's going to cost me that much energy. If I optimize my code for using that or this instead, I'm going to burn that much less. Do you think there's going to be some equivalent for edge AI and models and the ability to evaluate how much a model is going to consume based on the input and throughput and so on?
Yeah, absolutely. I mean, it's all about measuring. So, I mean, doing all models need to have data input. So there must be measuring in the background to see all this data. Absolutely.
I mean, I just think this is what we do all day. It's so I think what we typically do and what our customers are doing is using. We use Qoitech here in our office, but also our customers using this or something similar. You measure at the desktop level, and then hopefully, and what we always encourage people to do is then get those systems outside, and then you measure some more under a variety of conditions. So most people are doing. You start with one or two, and then you put out a pilot round of 50 to 100 systems, and you measure it and you see, and you're often you get some surprises, some edge case where maybe this is a classic one, but like let's say you don't have as good as connectivity, it takes a little bit more energy to send. If you don't have the right antenna, so you might start to see cases where you're using more energy than you expect and less, and then you can continually tune that. Because getting lower power means your panels going smaller, your battery storage is getting smaller. Like getting lower power just drives down your BOM cost, and that's everything. And so I think everything that you can do to drive down power is going to drive down your costs, increase uptime.
Yeah, definitely. And interestingly, when you were describing all of that, I used to work at Microsoft, and the team I was working within lately was about IoT, right? But they were building cloud services, and there's a big question that was asked by the teams that were collaborating with, that were in charge of the data centers, and they were looking at how, at a data center level, they could measure, leveraging IoT devices in that case, the energy consumption of the rack of servers, of the farm of servers, and optimize all of that so that they would consume less. And it was all about continuous measuring and adaptation and the right, the right share of the workloads and distribution of the workloads and so on. We are seeing the same thing at a different scale here, which is your sensors, your energy harvesting devices will need to be monitored in terms of their health and how they are, performing, so you can adapt them, adapt the software, adapt how you use them, adapt. And that's super interesting. You were saying adapt the antennas that you're using, adapt everything around the device itself. That is not just about the energy consumption or production, but you have to have an holistic approach around these energy consumption and production that includes consideration for everything on that embedded device.
Exactly. So, I mean, designing a device for one specific location, one specific use case, then it's getting pretty simple. But then you don't know where it's going to be located in all the time. What direction it will face.
Definitely. Well, so if you are an OEM building, or needing IoT devices and needing to have this energy harvesting, problem solved, so you will have to work with people like both of you guys. Work with the actual hardware manufacturers of these solar panels and batteries and so on, as well as people building the tools and having the expertise to tell you what to do in terms of measuring the performance, the efficiency of your systems. Where should people go to learn more about you, Jeff? What about you? So, what do you recommend someone if they want to learn more about Voltaic? What are you doing, and how to reach out?
Yeah, so we're at voltaicsystems.com. We love talking to customers and hardware engineers about their products, and we typically just have a short call and figure out what they're doing and how we can be helpful. And we talk to everyone from I've talked to college students building a product if they know what they're doing, as well as hardware engineers at Fortune 500 companies. So we're open to talking to everyone about these things.
Yeah, so at Qoitech.com, I mean, we have a lot of information, a blog, and a lot of articles on our homepage. But also, it is possible to book a demo. So we will be then talking to you, explaining how you use our tool in the most efficient way to optimize, and also all the possibilities working both with batteries and energy harvesting system.
Definitely worth the time and the energy. Just pun intended, or was not intended, but thank you, both of you, everyone. Thanks for chiming in. If you are considering or not yet considering, but are curious about ambient energy on IoT devices, these two gentlemen here are the people you want to talk to. Both of you, thank you for your time today. Bye.
Thank you so much.
Thank you.